Hi everyone, welcome back to this channel. In this video I'm going to show you how it looks like for the trigger line that coming up from the FieldFox, especially when you're doing the ERTA extended range transmission analysis connections. So there are some requests to know how the trigger line will look like. We know that it's a TTL signal, but is it a pulse, is it a DC? So in this quick video I'm going to show you how it looks like, and this is the setup that I have currently right now in the lab. So we have two FieldFoxes, and one is a source, one is a receiver. So you can actually look back at the previous video on how we set up for ERTA. So basically what we interested is this trigger in and out. If you look at the side of the FieldFox, the middle flap, there is a trigger out SMB connector. So this is where you need to connect to the trigger in, which is a SME connector on top of the FieldFox, and vice versa. On the receiver you need to have a trigger out from the middle flap SMB connector to the trigger in of this source FieldFox. So you're going to do all the control from this receiver, and you can place this source at the other end of the cable that you want to test. Basically, this is not our focus today on the cable side, and we really want to check on this trigger, how it looks like on the scope. So I've set up the scope to do the measurements. This cable is the trigger out from the receiver FieldFox, and this cable is from the source FieldFox. So channel 1 and channel 2, yellow and green. So currently I will stop it. Let's turn it on. And right now the FieldFox is not running, it's on hold. I'm going to start a single so that you can see what's going on. So I'm clicking it right now. So I'm just waiting for it to refresh. So this is how it looks like without any signal, and I will click again. So as you can see, there is a trigger pulse going on there. So I'm going to try again. I'm going to do a single here, and I'll trigger again just to make sure that we have 3 types here. So everything is stopped. Let's focus on that right now. And before that, let's move the, so let's say this is my trigger start, and this is my trigger stop. This is where I lift up my trigger, or you can also say that's the start and stop of the measurement. So over here you can see that it's inverse on both channel 1 and channel 2. Okay, you can really see that right now, how it inverse, and there's a low, there's a high on both channel 1 and channel 2 before that. And you can see that the duration between the start and the stop end of that trigger signal is about 112 milliseconds, when my strip time on FieldFox is about 291 milliseconds. There is a correlation between the strip time on the FieldFox versus the duration between these two start and stop gap, but I can't really find out the relationship within that, because when I change the number of points on FieldFox, it does increase the size of it. Okay, let's focus more on that pauses. Let's move it here. So this is what I mean when it is actually inverse between the two channels. So when channel 1 is down, channel 2 is up. So you can see that. So you need to go hand in hand, which I suspect. And the delta Y, the width, the height of the voltage is about 5.226, which is within TTL specs, I guess. So because anything above 3.2 volts is considered as 1. So this is how it looks like, and it's almost the same for the rest probably. So this I might have triggered that differently, so let's move it here. So it might be longer a bit. Yeah, it's about there. Alright, I will let it run, and I will let FieldFox run continuously. So this is how it looks like in real. Every time after the first measurement is done, you just continue on with that. so you can see that it's not really tally back to back. It's always, there's a pattern to it, so fast and then slow, fast, slow. I can zoom in a bit more so that you can see how it looks like. Can't really put a trigger to make it stay. There's a way to set it, but I'm not the expert for the scopes, so this is the best I can do it right now. So it looks like it's well within that. So the sweep time on the FieldFox is about 170 milliseconds. So again, we can pause it for now, and then I can change this to this one. No, 170 is not 127. But anyway, this is how it looks like. If you are interested to know how the TTL signal look like, or again, you can see that this totally different type pulse width and whatnot. So if you're interested, I can do a quick measurements right now. Let's say the small one is about, so the small pulse is about 90 microseconds, and the big one we have here, this X one, sorry, and 1.278 milliseconds, and we can actually zoom it out so we can see that there are some other patterns along the way. I won't really spend time looking into it right now, but if you're interested, please talk to the local Keysight Care team and ask them these questions. What is the TTL type of patterns that is needed to control or trigger measurements on the FieldFox if you have an external device that you need to use it as the trigger source. Thanks for watching.